The three mechanisms for heat transfer are conduction, convection, and radiation. Conduction is when heat travels through a solid material just by conducting through it. It's kind of similar to the word of like how electricity goes through a conductor or conduction of electricity, but this is for heat. I have a formula for that that says the amount of heat per a time interval is equal to the thermal conductivity. That's this little K thing right here. It's a constant called the thermal conductivity. That's generally a characteristic of whatever material the heat conduction is happening in. A is a cross-sectional area for that. Delta T is the temperature across it, and D is the length or maybe thickness. There's kind of two pictures I could actually draw for that type of a scenario. One of them might look like this. If I have two regions, maybe one of these is at like some temperature T1 and maybe this one is at T2, and in that sense that delta T, assuming maybe that T2 is the higher temperature, the delta T would just be the difference in those two temperatures. If I place a rod between those two, like a solid material rod between those two, then the D that's here in this formula for conduction, that is actually the length of that rod. In other words, it would be this length here in this picture. And if you took a cross-sectional area, if I kind of try to draw in sort of a cross-section there, that cross-sectional area A, I don't know if I can quite squeeze that in there, that's the area we're talking about. And again, K would depend on like, oh, is this a glass rod? Is it copper rod? Is it aluminum rod, etc. Convection is a heat transfer mechanism that involves stuff moving. So it can be any kind of fluid that flows. So it could be a gas like air. So commonly convection will cool us down if it's a windy day. But water can do it as well. A story that I've sometimes told about this is I was once going out river rafting. It was actually my first time, as I recall. And we had a raft that rapped on a rock. And everyone climbed out of the raft onto this rock that the raft had wrapped around, and it was right in the middle of this rapid, so nobody could get out to the shore. We were all kind of stuck there, but there wasn't enough room for me on the rock. I was the last one left, and my feet were in like swirling rapid in the raft. And my first thought was, oh shoot, convection, because there was all this moving cold snow melt water going around my legs, and I wondered how long it was going to be before I would catch cold, because a lot of heat transfer was going from my body into the water because it was moving and basically robbing me of my thermal energy, really maybe the better thing to say, as there was this continuous convection type of process going on. There's actually also convection that happens in the sun. The nuclear fusion that really powers the sun and ultimately creates the radiation that we receive from it, and of course it goes out into space, is actually transported from the core where the fusion occurs by convection currents of plasma to the surface, where it then radiates away as radiation, which is maybe a good way to step into the third category, which is radiation. And there is this equation here. This is an equation for the total amount of power emitted by an object through radiation as a function of its temperature. And it depends on the area. E is an emissivity constant, and this sigma thing is actually the Stefan Boltzmann constant, because this is a Stefan Boltzmann radiation law.